Yakir, old friend, how are you doing today?
I'm doing great. I'm very happy to be with you here after a long time.
Yes, I'm very happy to be with you here as well in your home in Tel Aviv, in your family's home. It's a beautiful place, and we're
Thank
going
you.
to do some physics.
As we always wanted.
Yes, we've been wanting to do this for a long time, and let's get going.
Yes.
So the way I'm going to teach you is by asking you very easy questions.
Mhm.
So the questions are very simple, and you just give the answer. It may sound trivial, so easy that it's trivial, but please just go with the system, and you will see that you will learn many interesting things on the way without even realize that you're learning.
I'm all for you.
Yeah, great.
Body and soul. I mean, just soul.
Okay. So we're going to start with the easiest subject, which is kinematics, and start with movement in constant velocity. So, like if you're going on a train, and the train is, let's say, going north, and it's going in 100 kilometers per hour,
Yeah.
and you're going for 2 hours. So how many kilometers did you go?
200.
200, very good. And if you're going for, if you've been going for, 3 hours, and you've traveled 90 kilometers, assuming your velocity was constant, what was the velocity?
300 kilometers.
No.
Per hour?
No, did I say 900 kilometers?
Yes.
Oh, really? I meant to say 90. Okay, very
Oh.
good. But very good, very good. And okay, now I want to introduce a concept of average velocity.
Mhm.
So let's say you started going, and at first you accelerated, then you decelerated, you stopped, whatever. But eventually you traveled 90 kilometers in 3 hours. So what
Okay.
was your average velocity at that time?
Hmm.
90 kilometers in 3 hours.
Well, 30, but
Exactly. Yeah.
Yeah,
30,
that's how you do it.
You
Ah,
see
it's
my.
simple,
Yeah, very simple. Good. Think simple. Very good.
Okay.
Good. So now we're going to see how we can calculate the average velocity.
Now, I'd like to have a letter to be represented by it. So, is it an AAV, average velocity? Or?
Yeah, you can do that. Yeah, AV.
Okay.
Very
I
good.
think simple. Yeah.
Very good. So here's the thing. So let's say we've been going 1 hour at 30 kilometers per hour. So how many kilometers did we travel?
Sorry, I was thinking about.
Yeah, no problem. 1 hour, 30 kilometers per hour. How
Yes.
many kilometers did we travel?
30?
Yes, there we go. So, and during that same hour, let's say we didn't move at all for 30 minutes, and then for 30 minutes, we went at 60 kilometers per hour.
Well, so it would be still 30 kilometers.
Very good. And now another step. For the first 15 minutes, we didn't move at all. And then for the next 15 minutes, we went at 20 kilometers per hour. And then the next 20 minutes, we went at 40 kilometers per hour. And then the next 15 minutes, did I say 20? I meant 15, 15, 15, 15.
Okay, so
Okay.
you said 15, we stopped. With
We
there's
stopped.
no, like,
Yeah,
we're
and
just
then 15.
biding our time.
Yeah.
But there's another 15, we go
With
5.
20.
Oh, 20
With
per
20,
hour. Okay.
And then another 15 is 40.
Which means we moved 5 kilometers. Then what did you say?
Yeah,
Then
good,
40?
good. Wait, yeah, very good, 5. And then another 15 minutes, we go 40,
Uh-huh.
which is how many?
Yes, it is 10, I think.
10, very
Yeah.
good, very good. And then so in
Well, you know.
so in the first 45 minutes
That's
in
my
total,
way of thinking. Huh?
in the first 45 minutes,
15.
very good. And the last 15 minutes, we went at 60 kilometers per hour, which is
15.
15. So
Yeah.
in total, we
30
traveled
kilometers.
30, exactly, just as before.
Yeah.
So as you can see, we are cutting this hour into smaller and smaller pieces. But as long as the acceleration rate in each piece is the same, and we start with 0 and we end at 60, we are still staying in 30 kilometers distance during this 1 hour.
Yeah.
So and you can do this. We can keep on cutting it into smaller and smaller pieces and say, okay, the first 12 minutes was like this, and then the next 12 minutes, and so on. But we don't need to go there. You just trust me, right?
Yes.
You can do that later if you feel like. So, so here's the trick we are learning from this. If our velocity is changing at a constant rate, in regular intervals and same acceleration, now we just take the initial velocity and the final velocity, and we take the average of those two, and that's our average velocity. So 0 and 60, the average would be 30, obviously. Yes.
How you do this? Again, say it again. 0. You say you divide you divide in 2.
Yes, you take the sum and you divide
plus,
it.
Yeah, okay.
Yeah, for example, if the initial velocity was 10 and the final velocity was 20, then the average velocity 15. Yes. Okay, great. So we are done with the subject of kinematics, and finally we are going into not just movement, speed, time, etc., but forces. We're going into Newtonian physics.
Is that why we ate an apple just now?
Yes, exactly.
Oh, okay, yeah. Makes sense.
Yeah. So when you hold an apple in your hand and you drop it,
I drop it, yeah.
Yeah, you drop it.
I'm dropping it, yeah.
Good, drop it. So so after the initial velocity is 0 because you dropped it, you didn't throw it. But after 1 second, the velocity will be 10 meters per second. This is a fact that I'm giving to you. Okay. So if the initial velocity was 0 and the final velocity was 10 meters per second, what was the average velocity during that 1 second?
5.
5, very good. So if the average velocity was 5 meters per second and the traveling time was 1 second, what was the distance?
5 meters.
Perfect. So now you have an intuition. If you drop something from your window, you don't know which floor you are on, and you drop something and you hear it bang after 1 second, you know it's 5 meters. Yeah.
Okay.
Okay.
Wow. Is it always like that?
Yeah, it's always like this.
No matter where you are?
No matter where you are,
Wow.
even on the top of the Himalaya.
Oh, that's great.
Okay.
Yeah.
If you are, somewhere higher up in space, it will be a little different, but Himalaya is pretty short.
Okay.
Okay.
Of course.
So, and it continues on like this. This is a constant acceleration. So after 2 seconds, it will be 20 meters per second. The velocity will be 20 meters per second after 2 seconds. So if in the beginning, after 1 second, we had 10 meters per second. After 2 seconds, we had 20 meters per second. What was the average velocity in the second? Between 10 and 20.
Then it's 15.
15, good.
Yeah.
And how much did you travel in that second?
10.
15. The average velocity was 15.
Yes.
And we traveled for 1 second.
No, so 15, but what about the 5 from before?
Oh, no, I just asked about the second.
Ah, okay, so 15.
So 15.
Yes.
If you want to say the first 2 seconds together,
yes.
then you had how much from the first second?
Then we have 20.
20, exactly. Very nice. Do you want to do the third second to see how much we traveled on the
Sure.
Okay.
Sure.
So you want to tell me?
So in the third second we would have 30.
30. Let's see.
But maybe not. Maybe 40. I mean, we started with 10 meters per second.
No, at the third second.
Yeah.
We start with how much?
No, but the first. How many?
Okay. In the first moment when we dropped it, it was 0, right?
Yeah.
And then after 1 second.
It was 10 meters per second.
And after 2 seconds.
It was. Did you say 20?
20, yes. And after 3 seconds.
I mean, then it doubles. It's 40.
That's a good guess. Good guess. Very good. I like your guess. It's mathematically you're absolutely correct, but it's easier than that. It's just 30.
Oh, okay.
It goes 10, 20, 30, 40, etc.
okay.
Yeah, I know it sounds.
Every object, it doesn't matter its
Yeah.
size, its weight, no?
Yeah, that's Galileo. That's Galileo who dropped like an egg and a watermelon from the Leaning Tower of Pisa,
Oh,
and
wow.
you saw they
Cool,
fall
yeah.
at the exact same time. But of course, if you drop a feather, it will take longer. But if it's something more or less round, then it doesn't really matter the size and the weight.
Yeah,
Not so much, unless it's really huge or something.
yeah.
So
Huge, you don't mean a ton, but
well,
much more.
also, I mean, if you drop like, like these beach balls
Yeah,
that are extremely light but they're quite big.
yeah.
So also, if you drop that, also it will take a little longer, than if you drop. an
Really?
egg.
Why?
There's some air resistance.
Ah, okay.
Okay, but let's go back
Yes.
to our our journey. So we said it goes the speed, the velocity goes 0, 10, 20, 30, etc.
Yeah.
So now try to do the third second, please. Oh, by the way, according to your mathematical guess of 10, 20, 40, 80,
Yes.
100, etc., your guess of 30 meters on the third second is absolutely correct. Yes?
Yeah.
I asked you to tell me how much was on the third second.
Yes,
And you
I
did the
said-
average between 20 and 40, which was 30. So you gave me the correct answer. The thing was, you gave me a little bit overcomplicated guess. Like, it's really simple, it's just 10, 20.
Typical me.
Yeah.
Okay. There
Okay.
we go.
So now can you give me again, please, the distance done on the third second?
You
If
said,
you like.
So you said 30 is the velocity, average velocity.
No, 30 was we said the final velocity.
Yes.
Yeah, okay. So what?
So I calculate between the first velocity, which is 0,
Oh, okay.
and the last one, which is 30.
Okay.
And you say I divide this by 2, and it's
Yeah.
15.
Okay.
And so I add 15 meters.
Okay.
And before we had 20. And
Oh,
now
wait.
we have 35.
But listen, maybe my okay. Listen, if you're doing the average velocity of the first 3 seconds together, then the average velocity will be 15. Yes.
Yes. You
But-
take the first velocity and the
wait,
last, yeah?
exactly.
Okay.
But that's the average velocity of the whole
All
first
the fall, yes.
all the fall together.
Yes.
So the time that took was 3 seconds, right?
Yes.
So if we were traveling at an average velocity of 50 meters per second for 3 seconds, what was the distance of the whole first 3 seconds together?
And then it is 45.
Perfect, wonderful.
Yes.
And the first 2 seconds we did before. The first second was
5.
5, and the
Then
second second
15
was 15. Very good. So together
is 20.
is 20, and the whole 3 together is
So then we have 25.
25 on the third second.
Yes.
Wonderful. That's a very good
Again,
way.
complicated way, but good
Yeah,
answer.
you can. Let's do it the other way. Let's do it
Okay.
just the third second. So when the third second started,
Yes.
the velocity was. Do you remember?
The velocity was 30.
Oh, no, that's the end of the third second.
Oh.
The beginning of the third
I see,
second.
I see.
Was?
It was 20.
20 exactly.
Yes.
So the average velocity during the third second.
Was 20.
Wait, how 20? It started in 20, and
Yes.
in the end it was
30.
30. So the average velocity.
I see. 25.
25.
Okay.
So you see, this is an easier calculation.
Mhm.
But it's great. So now you're standing. Let's say which floor do I live in Petah Tikva?
You made me climb that by feet one time. I couldn't believe you. What was it? The 19th? The 12th? What?
30.
30,
So you're
yeah.
on some floor. You don't know which floor you're on, but you drop something out the window. If you hear it bang after 1 second, you know what was the. How high are you?
5 meters.
5 meters. And if you hear it bang after 2 seconds,
Oh, then it means that it is 20 meters.
and after 3 seconds,
Then we say 45.
45. Yeah.
Yeah.
So I think 45 meters is more or less like 15th 15th floor.
Mm-hmm.
So if you do it from my home, then it should be like more or less that much
So in
time.
other words, if we throw a football from your window,
Problem is you
living
won't.
room's window.
Yeah. Problem is you won't hear it, crashing on the ground. You would have to, drop a bomb or something so you can hear it.
Well, let's not go
We'll
that
see.
way. I'm sure I'll hear the neighbors on your
So listen,
door. Yes.
one more thing is that it also works if you're throwing it up. So I want to ask you to guess, and please, my principle is keeping things simple.
Mm-hmm.
So think of a simple answer. If I throw something up
Mm-hmm.
at 10 meters per second,
Mm-hmm.
that's the velocity, the initial velocity,
Yes.
up. I'm throwing it up.
Mm-hmm.
What do you think its velocity will be after 1 second? Just a guess,
20? But there's the force of gravity. That
Yeah,
converts.
exactly.
Yes. So maybe we have it.
We have it. What do you mean we have it?
We have it.
We have it. Oh, make it half.
Yes.
Okay, listen. If we let's think about it like numbers. Okay, so
Yes.
let's make an axis with a direction going down. Okay, and so when we say down would be positive and up would be negative.
Mm-hmm.
So if we have a
But
positive,
how come? It's
it's
down
just
that's
an
negative.
arbitrary choice. It doesn't matter. You can do it either way.
Okay.
So if we have a velocity going down
Mm-hmm.
of let's say 100 meters per second,
Mm-hmm.
after 1 second, what would be the velocity?
50?
Oh wait. The velocity down was if the velocity
Well,
down
so
is
down what?
Down-
Did you throw a ball down?
yeah, I'm throwing a ball down and the
Yes.
velocity down is let's say 10 meters per second.
Oh, I see.
After 1 second,
Then it's 110.
110 exactly.
Yeah. I
Okay,
see
very
what you
good.
mean.
110. So if you're throwing it up, it's minus 10. The velocity is minus 10.
Mm-hmm.
So after 1 sec, so you add 10 every second. So if it starts with minus 10, what would be the velocity after 1 second?
90.
If it starts from minus 10,
Oh,
what
it
is
starts with then zero.
Yeah, zero.
And
Very
it
nice.
stops.
And it stops in midair, yeah?
Wow.
Which is natural. That's what you happen. You throw something up, it decelerates and it stops eventually.
Yes.
Okay, and then it begins all over again. It starts from zero.
But what is the velocity of minus 10?
Oh, it just
Basically
means
the thought of throwing the ball, but what is it?
it's just a way of talking about things.
Okay.
When I
It's
say minus, I
mathematics,
just
yeah.
mean it's up. Yeah.
Yeah.
Okay. So and then after we threw it up at 10 meters per second and it stopped after 1 second. So it stopped and after 2 seconds, what would happen? What would be the velocity? Let's say.
I mean, it starts going down again.
Yeah,
no?
it starts
the
going
ball
down.
starts going down, and it would be again 10 meters per second.
Yeah, very good. 10 meters per second.
Mm-hmm.
So, wow, this is a really good. I really like this lesson. This is a really good video. We're almost going 20 minutes. I don't know how it will work if I want to upload it like on the internet or something. But I'm gonna try to keep doing it on one take, and maximum I can edit it afterwards.
Great.
Okay, so we threw something up at 10 meters per second. After 1 second, it stopped, and then after 2 seconds, it landed back in your hand.
Mm-hmm.
So if you throw something up and it takes it 2 seconds until it falls back in your hand, you know how high you threw it up, yes?
Yes.
And you know what was the velocity also.
Yes.
So let's say something like this. Okay, I'm going to challenge you a little bit, okay?
Okay.
So let's say you throw something up, and after 4 seconds, it falls back in your hand.
At the 4th second.
At the 4th second, yes.
Okay.
So how fast did you throw it up?
Well,
I'm sorry, I'm making a difficult question. I'm
Maybe-
breaking my own rule.
in other words, the initial velocity.
Yeah, what was the initial velocity? If it took it 4 seconds to go up and down, what was the initial velocity?
I mean, without thinking, I would say minus 20, but
Wonderful!
Really?
Minus 20, bravo! Yeah,
Great.
genius.
no, I just
And-
need to not think.
Yeah, exactly.
key.
That's the key to life, not thinking.
No think.
No think,
Ladies and
yeah.
gents, we have something for you here. We
Don't
hope
think.
Yes.
Especially in physics.
Well, just when you go to the bank, it's different, but otherwise. Yes.
So,
and your marriage decisions also. Anyway, yes. Let's proceed. Yes.
Okay, so when it was this procedure, like throwing up after 4 seconds, it lands in your hand, and you said the initial speed is minus 20. Okay, so how high did it go? What was the maximum height?
Yes. 15.
15, yes.
Great.
15?
Yes.
Yeah, yeah. 15?
I think so.
Think again.
Because the first. So wait, so we started at minus 20.
We started minus 20.
So we go up 20 meters. No, you're right.
Yeah,
We go
up
up
20.
20
Yeah,
meters.
okay, this is a minor, it's not important. You know the answer.
Then 30, probably.
No, 20 was
20,
good. 20 was good, yeah, because it's the same, it's
But I'm
not
assuming
important.
it went 2 seconds up and then
Yeah,
2
2 seconds
down.
up and 2 seconds down.
Yes.
Oh, yeah, so I meant, because
Did
you
you go
remember.
30 meters up?
No, just 20, because you remember we did this calculation going down, remember?
Yes.
We said the first second, something going down, the first
That's
second
10, yes.
was, no, and the distance.
Mhm.
What was the distance covered in the first second?
5 meters.
5, and on the second, only on the second, how much distance?
15.
15, and together?
Ah, yes, I see. 20,
Yeah, you
yes.
see. So sorry,
That's how it is,
it's okay.
yes.
You know the, you know how to do things. That's the important
Well.
thing. Not okay.
But w-
Not to remember not to
Overguess.
remember a thing.
Yes.
No, overguessing is fine. No, actually, what I'm saying, what's important is not that you remember that in 2 seconds it's the total distance is 20 meters. That's not important. What's important is that that you know how to calculate it.
Not to win the game, but how to play it. says Van Gogh.
Exactly. Wonderful.
Yes,
Yes, that's the thing. So okay, so we spoke about throwing up. We spoke about throwing down. Now we're going to throw horizontally.
Wow.
Okay. We're
Okay.
going to throw horizontally. So let's say
Things are
you're
heating up here.
yeah, things are heating up.
Yes.
So let's say okay, when you throw something horizontally, you can address the two velocities. You have one velocity going horizontally and one velocity going vertically.
Mhm.
Okay.
Yes.
So the vertical velocity will behave exactly as before because you are throwing horizontally. So the initial vertical velocity is 0.
Mm-hmm.
So if I'm throwing something horizontally, it doesn't matter how fast I'm throwing it.
The vertical velocity.
So if I'm let's say I'm 5 meters off the ground
Mm-hmm.
and I'm throwing something horizontally, it doesn't matter which speed I'm throwing it in horizontally.
Mm.
But how many seconds would it take for it to hit the ground? If I'm 5 meters off the ground, how many seconds?
1.
1,
Yeah.
precisely.
Mhm.
Yes, very good.
But how can it be? Because if you throw it so hard.
Well,
that
if you
doesn't
throw
go-
it hard enough that it leaves the planet, then of
No,
course.
no. But if you throw it, I mean, obviously, if I throw a ball very strong, it will travel for more than a second before it hits ground.
It will travel far more. Well, maybe because you're not throwing it perfectly horizontally.
Oh
You're
yeah.
throwing it a little bit in an angle upwards.
Mm.
Yeah. Let's. We're going to do that in a short while. Throw things at an angle. Okay?
Well, let's
Yeah.
avoid the mirror. Yes.
Yeah, no problem. So
Still
I just
mind.
want to introduce this calculation. It's very easy. So I'm still, let's say, I'm still 5 meters off the ground, okay,
Mhm.
and I'm throwing something horizontally at a velocity of 10 meters per second horizontally.
Mhm.
So how much distance would I travel horizontally until I hit the ground?
Say it again. How much?
Very good that you're asking me to repeat the question. Okay, it works like this.
You said it's 1 second, no?
Yeah, it's 1 second, exactly.
Mhm.
And if I'm throwing something horizontally at 10 meters per second,
Yeah.
and I'm throwing it at a height of 5 meters
Meters.
over the ground,
Mhm.
then how much distance would it cover
No,
horizontally?
Horizontally. 10.
Horizontally.
10.
10, perfect.
Yes.
Very good.
Mhm.
Good. And I can ask you if I'm throwing it at the same horizontal velocity of 10 meters per second,
Mhm.
but I'm starting at 20 meters over the ground,
Yes.
then how much distance would it cover horizontally?
Still 10.
Wait, but I'm higher off the ground,
Mhm.
20 meters off the ground.
Yes. But you're asking me how much horizontal distance?
How much horizontal
Distance.
distance it would cover until it hits the ground?
Oh, until it hits the ground.
Yeah.
Oh, I see.
So if I'm 20 meters off the ground,
And you throw it at 10, I mean, you need 30 meters here.
wait, what do you mean 30 meters?
Because if you're 20 off the ground
If-
and you're throwing it for 10 meters,
Yeah.
You say
no,
how
no,
much-
no. I'm throwing it at 10 meters per second horizontally. Yeah.
So
Right.
it goes 5 meters straight,
Okay.
and then it falls for 20 meters because you are 20 meters off the ground. So 25
Interesting.
meters.
Okay, let's take it step by step. If I'm 20 meters off the ground
Yes.
and I'm just dropping something, how long would it take it to get to the ground?
We said 2 seconds.
Perfect.
Yes.
And if instead of just dropping it, I'm throwing it horizontally at
Yes.
10 meters per second,
Yes.
and the time it takes it to hit the ground is how much time? How many seconds?
If you throw it horizontally,
I throw it horizontally.
at a horizontal velocity of 10 per second,
10, yes.
meters per second.
And it's 20 meters off the ground, so it takes it 2 seconds to hit the ground.
Um,
Then the horizontal distance.
I don't know because maybe it would be 2 seconds anyway.
Maybe you're thinking too much, I think. Right? You're thinking too much?
I mean, I can say 3 seconds without thinking.
Wait. Yeah, sure. It's good. Say 3 seconds. It's the best answer. But anyway, look, it's like this. As we said, it doesn't matter. The horizontal and vertical speeds don't affect each other. So if I drop something 20 meters off the ground,
It still takes 2 seconds.
it still takes 2 seconds, no matter what's the
I
horizontal speed. So it takes 2 seconds to hit the ground, and I'm traveling horizontally at 10 meters per second.
Oh. Yes.
Oh, so the answer is?
So of how much distance?
Yeah.
Okay, so the first meter, let me think, it's
Oh.
5, and then the other, the first horizontal
Second.
second.
The first
it's-
second.
It's 5 meters horizontally, and then the second.
It was 15, yeah.
Yes.
Oh, wait, horizontally?
Yes.
No, the horizontal speed is constant. It's not affected by gravity.
Ah, okay.
Yeah.
So we are always 10 meters per second.
Yes, exactly.
Okay, so we go 10, and 10 is 20,
Perfect.
and then another 20 meters to fall down, and that's 40.
Oh, you're
I'm combining
thinking...
the two distances.
Oh, no. Just tell me the horizontal.
Oh, okay, so 20.
Good.
Okay.
Okay, good. Okay. Good. And if I'm still throwing it horizontally at 10 meters per second, but this time I'm 45 meters off the ground.
Wow, gee.
Okay? Just give me just the horizontal distance, okay? What's that?
So you're
I'm
45,
45 meters off the ground.
off the ground, and you
Yeah.
throw it at 10.
Meters per second.
Well, then that is 30. No,
Yes,
30. Okay.
30. Very good.
Yes.
Perfect.
It's sort of like Michel Thomas in physics, but yeah.
Yeah, great. That's... Shh, don't tell anyone.
Yeah.
Okay,
We lack the pretty girl with the stupid answers, or maybe it's me, I
Hey,
don't know.
no.
Okay.
No.
No chauvinism, you know.
Yeah, shh. Yakir, you're a famous person now. You have to be
politically correct.
Yeah,
You're
you have to
very
be.
right.
Yeah, this goes online, you know.
I mean,
Well,
I love you, women.
Okay, listen, I'm really grateful.
Nothing against you.
I'm so happy we did this, and it's been
finally, yeah.
so much fun, and I feel like you can do so much more. So I'm just looking forward to next time where I have more stuff to teach you. I'm going to stop here because it's I think it's just a good place to stop.
It's been great. Thank you
Yeah.
very much. Finally, we do this. Yeah.
Yay, bravo!
Shake hands, shake hands. Peace in the Middle East, ladies and gentlemen.
Yeah, peace
There
in the
we
Middle
go.
East.
There we go.
Yeah, physics in the everywhere.
See
And
you
listen
soon,
to this
guys.
guy's music; it's great.
Thank you.